Good afternoon, viewers. Yesterday I told you about the standard deviation, all the formulas, coefficient of variation. Okay, I completed that. And after that, variance. Variance is equal to standard deviation square, or standard deviation is equal to square root of variance. Now after that, like how we come across mathematical properties in arithmetic mean. In the same way, we'll come across mathematical properties of standard deviation. In this mathematical properties of standard deviation, we have to find out the combined standard deviation of two groups. When two groups are given, and when you have to find out the combined standard deviation of two groups, okay, what is the formula that we have to use? Okay, sigma 1 2 is equal to, I told you already that we should not call that as sigma 12. We have to call that thing as combined standard deviation of two groups, sigma 1 2. So the formula is square root n1 sigma 1 square plus n2 sigma 2 square plus n1 d1 square plus n2 d2 square by n1 plus n2. So here n1 is number of items of first group, sigma 1 is equal to standard deviation of first group, n2 is equal to number of observations of second group, sigma 2 is equal to standard deviation of second group. And here you have to find out what is d1. d1 is nothing but the difference between the variables as well as the arithmetic mean, that is x minus x1 minus bar x1, that is nothing but d1, deviations from arithmetic mean. And d2 is equal to sigma x2 minus bar x2, that is standard deviation of second group. Okay, standard deviation of second group. And this d1 is equal to x1 minus bar x1 2, that is combined arithmetic mean of two groups, x1 minus bar x1 2. Similarly, d2 is equal to x2 minus bar x1 2, combined arithmetic mean of two groups. So this is how you can calculate the standard deviation of two groups, and this can be extended for three groups also. What is the formula for that? Sigma 1 2 3 is equal to square root n1 sigma 1 square plus n2 sigma 2 square plus n3 sigma 3 square plus n1 d1 square plus n2 d2 square plus n3 d3 square by n1 plus n2 plus n3. So here d1 is equal to x1 minus bar x1 2 3, that is combined arithmetic mean of three groups. Okay, d2 is equal to x2 minus bar x1 2 3, that is combined arithmetic mean of three groups. Okay, and n3 is equal to x3 minus bar x1 2 3. This is the combined arithmetic mean of three groups. Now after that, we have to take into account the standard deviation of the first 1 to 10 natural numbers. So what are they? What is the formula for that? Okay, standard deviation of n natural numbers. Okay, the formula is sigma is equal to 1 square root 1 by 12 into n2 minus 1. This is nothing but the standard deviation of n natural numbers. Okay, now after that, we will take into account the relationship between the three values, that is except the range. We have to take into account quartile deviation, mean deviation, and standard deviation. Here quartile deviation is minimum, then comes mean deviation, then comes the standard deviation. So what is the formula for this? QD is equal to 2 by 3 into sigma, 2 by 3 into sigma, or sigma is equal to 3 by 2 into QD, quartile deviation. Next, coming to mean deviation. Mean deviation is equal to 4 by 5 into sigma standard deviation, or 5 by sigma is equal to 5 by 4 into mean deviation. Like this you will come across. When you take into account another comparison, okay, taking into account the arithmetic mean, bar x plus or minus qd includes 50% of the items, bar x plus or minus MD includes 57.31% of the items, and bar x plus or minus standard deviation includes 68.27%, or about two-third number of the items. This is about standard deviation. And after this we'll come across skewness. What is skewness, sir? Okay, before going to skewness, we have to observe when a normal distribution, when it is plotted, okay, graphically, you'll come across a symmetrical distribution. Symmetry means, okay, it will be in a bell shape where arithmetic mean, median, and mode are coincided, or will coincide. And if anything, if it is not coinciding, then we'll call that thing a symmetrical distribution or skewed distribution. And when you go for skewed distribution, okay, different formulas are there regarding the calculation of skewness. Okay, absolute measure and relative measures I'm going to explain in this class. Skewness, that is a symmetrical distribution where arithmetic mean, median, and mode, they are not same, they won't coincide. Okay, either mode will be more or arithmetic mean will be more. Generally arithmetic mean will be more than median and mode values. So this is a symmetrical distribution or skewed distribution. There are different formulas, okay, coming to this skewed distribution. Okay, what are the formulas that we come across? Three persons by name Carl Pearson, Professor Bowley, and Kelly. These three persons, they had given different formulas for this skewness. What are the formulas that we come across regarding this skewness? Okay, when you go for the formulas, okay, Carl Pearson, he had taken into account the difference between mean and mode. Okay, that is nothing but the absolute dispersion, absolute skewness. When you take into account arithmetic mean minus mode, it is nothing but the absolute measure of dispersion between the values. And what is the relative difference that we come across? The relative measure is SKP, that is SKP stands for Carl Pearson's or Pearson's coefficient of skewness. SKP is equal to mean minus mode by standard deviation. So whatever it may be, the difference that we come across between mean and mode, that difference we have to divide with standard deviation. That is nothing but the relative measure of skewness. Now after this we have to take into account the Bowley's formula. Bowley, instead of going for arithmetic mean, median, mode, that is measures of central tendency, what he had taken is, he had taken into account the quartiles as well as the median. Okay, what is the absolute measure that we come across? The absolute measure is equal to, okay, the absolute measure is equal to, and before going to Bowley's coefficient of skewness, we'll come across one more formula, that is when mode is ill-defined. When mode is ill-defined, how to calculate SKP, that is Carl Pearson's coefficient of skewness. SKP is equal to arithmetic mean minus 3 median minus 2 mean. That is, we have to take into account the empirical formula. So x minus, that is arithmetic mean minus 3 median minus 2 mean, when divided by standard deviation. When you simplify that, it will give you the formula 3 into bar x minus median by standard deviation. This is the formula that we will come across when mode is ill-defined. Now we are going for Bowley's coefficient of skewness. Here, I told you already that Bowley had taken into account the quartiles, that is the first quartile, third quartile, and as well as the mean. Okay, as well as the median. So here Q3 plus Q1 minus 2 median, it is nothing but the absolute measure for calculation of skewness. Now, what is the relative measure? SKB is equal to, that is Bowley's coefficient of skewness. SKB is equal to Q3 minus median minus Q1 by Q3 minus median minus Q1. If you simplify this, you will come across Q3 plus Q1 minus 2 median by Q3 minus Q1. This is nothing but Bowley's coefficient of skewness, that is SKB. Now I am going for this Kelly's measure of skewness. Here you won't take into account the Pearson's coefficient of skewness as well as Bowley's coefficient of skewness, because this thing, when we go for Carl Pearson's or Bowley, they'll take into account some portion of the data, given data, but they won't take into account the complete data. They will leave the extreme values. So Kelly, what he had done is, he won't take into account the arithmetic mean, mode, like that. Similarly, Q1, Q3, median, he didn't touch that. What he had done is, he had taken the deciles as well as percentiles, thereby to cover the extreme values, okay, without leaving any portion. So Kelly's formula, SKK, that is Kelly's coefficient of skewness, is equal to, okay, Kelly's coefficient of skewness is equal to P10 plus P90 minus 2 median. This is the absolute measure. So what is the relative measure? That is coefficient of correlation. According to Kelly, SKK is equal to P10 plus P90 minus 2 median by P90 minus P10. This is by taking into account the percentiles. Now, he had considered the deciles also. So, what is the absolute measure? What is the relative measure? So, D1 plus D9 minus 2 median, it is nothing but the absolute measure. Now, what is the coefficient of skewness according to Kelly? SKK, that is Kelly's coefficient of skewness is equal to D1 plus D9 minus 2 median by D9 minus D1. This is the formula according to Kelly regarding this skewness. And after skewness, okay, after skewness, we'll have to go to kurtosis, because the measures of central tendency and measures of dispersion, they won't cover in completely the data, and this skewness, that will take into account the direction, that is whether the distribution, when we plot in a normal graph, in what way it is, that is whether it is symmetrical or asymmetrical. When it is symmetrical, the arithmetic mean, median and mode values, they will coincide, that is they will be one and the same. When there is asymmetrical distribution, okay, either one of them, they may be long. And in skewness, we will come across positive skewness as well as negative skewness. When mode is more than arithmetic mean, when mode is more than arithmetic mean, it is a positive skewness, and when arithmetic mean is more than mode, then it is negative skewness. So we will take into account the direction of the thing, but kurtosis, it won't take into account the direction, it will take into account the flatness or bulginess. Kurtosis in Greek, it means bulginess. When you go for this, okay, statistics will take into account the flatness. So that thing you have to take into account. So we have to go for kurtosis in order to find out the differentiation between two distributions as well as one distribution. Okay, it will give importance for flatness. It will give importance for flatness. That is the thing that we'll come across when we go for kurtosis. Okay, when you go for kurtosis, you will come across three types of kurtosis: mesokurtosis, platokurtosis, and ordinary kurtosis. That is leptokurtosis, mesokurtosis, and platokurtosis. These are the three things that we will come across, and they will indicate us about the flatness of the thing. So, kurtosis, I told you already that kurtosis in Greek means bulginess. In statistics, it refers to the degree of flatness or peakedness in the region about the mode of a frequency curve. The degree of kurtosis of a distribution is measured relative to the peakedness of normal curve. According to Spiegel, kurtosis is the degree of peakedness of a distribution usually taken relative to a normal distribution. Measures of kurtosis tells us the extent to which a distribution is more peaked or flat topped than the normal curve. And we will have three types already I told. If a curve is more flat topped than the normal curve is called platokurtosis, and the normal curve itself is known as mesokurtosis. And if the curve is more peaked than the normal curve, it is called leptokurtosis. So these are the various types of kurtosis or flatness or peakedness that we come across. Here in kurtosis, we will come across the values, that is the mathematical values we will come across. Okay, coefficient of kurtosis directly will take into account beta 2 is equal to nu, this is a Greek letter, please, mu 4 by mu 2 whole square, where mu is nothing but fourth movement and mu 2 is equal to second movement. This is nothing but, okay, this is nothing but the kurtosis formula. Okay, when you go for this, okay, the value of a normal curve will be beta 3. So from this beta 2 and beta 3 you can find out the correlation, that is you can correlate beta 2 and beta 3. So R2 is nothing but R2 is equal to coefficient of correlation, R2 is equal to beta 2 minus 3, because beta 3 is always equivalent to 3. For a normal distribution, R2 is equal to 0. In R2, if the R2 is positive, the curve is leptokurtosis, and if R2 is negative, the curve is platokurtosis. So like this, you will come across the calculation of kurtosis, which will take into account the peakedness or the flatness of a normal distribution. Tomorrow we will go for the details regarding this kurtosis. Okay, until then, have a nice day, and tomorrow we are going to meet in the next class regarding this statistics formulas. One thing I have to tell you is, unless otherwise you won't perfect the formulas perfectly, you cannot do any problem, because every problem in statistics they requires the requirement of the formulas, and every person they must be well thorough with this formulas. Then only you can be in a position to do the problematic portion. So tomorrow I'm going to continue, and if there is any person to subscribe, you can subscribe, and please subscribe for my inspiration. And again I'm telling you one thing, that those people who want online tuitions, okay, I'm giving my cell number 9849238902. This is my cell number. You can contact and you can take the tuition, online tuition. Okay, so thank you, and we'll meet you tomorrow.